on both sides. So here's the deal. Now you can do this on other proofs as well. There's more than one way to prove things. But what you want to be careful about is we want to prove that this side equals this side. So you want to make sure that you don't move anything from the left side over to the right side, because we're trying to show that they're the same. But what you may do is try to simplify both sides to get the same thing, as long as you're not moving things across the equal sign. So, what are your ideas, I guess? Where should we start? Let's start over here rewriting with sines and cosines, okay? So I'm going to rewrite this as cosine of u over sine of u. How could I rewrite this? 1 over cosine of u. And how about this? Okay, so I'm going to go one more step and see if I can simplify, and then I'm going to see is there anything I can do on this side, okay, to get to the same spot. So if I simplify this and distribute that, what happens when I multiply those two things together? I get 1 over sine. How about here? Isn't that just 1? Don't the cosines cancel and the sines cancel? Yeah. Okay. All right. So this is getting pretty simplified. Let's see. Can I do one more thing? 1 over sine is the same as no. Cosecant. Yikes. Okay. All right. So. Now, I see that I have some cotangent stuff there. Here's what I'm going to try to do now. I'm going to try to get this side to be cosecant u minus 1, because this is pretty simplified. There's not much more I can do with that. And what I'm going to do is I'm going to use a Pythagorean identity, because maybe you've noticed, maybe you haven't. Pythagorean identities are differences of squares when we rearrange them. Okay, and so what that's going to allow me to do possibly is cancel something out. So either look it up or tell me, how could you rewrite cotangent squared? But how could I rewrite it to change it to be a cosecant? Because I want to keep that in the problem. So 1 plus cotangent squared is cosecant squared, correct? So what can I swap out for cotangent squared then? Cosecant squared minus 1. So I'm going to replace the top now with cosecant squared minus 1. All right. Here's the nice thing about rearranged Pythagorean identities. They are differences of squares, so we can factor them. What that's going to allow me to do is cancel the top and bottom out. You can't do it now, but how could you factor cosecant squared minus 1? It's a difference of squares. What would it factor into? Very good. Oops. Cosecant u plus 1. Cosecant u minus 1, and what's on the bottom? Still that, correct? Just so you can see it, I'm going to rearrange the order and write it as cosecant of u plus 1. Alright, do you see the point of me doing that? Because now what can I do? I can cancel a factor of cosecant of u plus 1. By the way, I'm canceling this whole factor. And I am left with cosecant of u minus 1, which is, okay, So that's a little bit of working with both sides. Hopefully you can see that I never moved anything from this side to the other side, but I was just simplifying both sides. So that's something that you can use as well. Going back, let's go right in the things we used, okay? What did we use right here? Good. Okay. And then here we rewrote, so we used just quotient and reciprocal properties. You can call them identities or properties. So those would be my justification. Okay, does that make sense? Okay, so then the last thing I want to show you is how we can disprove something. And so first of all, we would want to know if it's true or not, okay? So this one I'm going to give you, prove or disprove this statement. And the statement is, does the cosine of 2x equal 2 times the cosine of x? Because a lot of times people want to do that. Can we pull that 2 out to the front? Okay, now, let's say we were dealing with some values. I'm guessing it would work some of the time. But what's a way that I can check and see if they're the same? Right? Graphing calculator, let's take a look. It's a cosine 2x. Does that equal 2 cosine x is my question. Okay, so I'm going to graph it and then I'm going to explain why not. Oh shoot, I'm in degree mode. Hold on, now I got to wait for that one to graph. Well, they didn't equal each other in degree mode, so they're not going to. There we go. So this is cosine of 2x. Okay. Now let's just think back, guys, to graph. Cosine of 2x still has an amplitude of 1, right? It's a horizontal shrink of 1/2. 2 cosine of x has no horizontal shrink and a vertical stretch of 2. So in our heads we can say, oh yeah, they aren't the same. Now, do they have some overlapping values? Sure, there's some points that you can find that they have in common. But they are not the same. And so the way that we disprove is we only have to find one case. It's called a counterexample. We have to find one case where it's not true. Sure. So we're going to say let x equal 0. The cosine of 2 times 0 is equal to the cosine of 0. What's the cosine at 0? Unit circle, guys. What's the cosine? There you go. Okay. So cosine of 2x at 0 is 1. 2 times the cosine of 0 is 2 times 1 or 2. Therefore, have I showed you this before? Therefore, do you have to write there? No, you don't. I'm just showing you stuff, guys. So you're smarter. Okay? Those 3 dots in math is a symbol for therefore. Therefore. Then you don't have to write out therefore anymore. Okay. You with the jokes today. All right. Therefore, cosine of 2x does not equal 2 cosine of x. So this would be my proof. My disproof.